Format of IP address. Calculating the network and host part of an IP address. Consider an example known to us. We all use the phone. By phone number, we can call any locality. How is this possible? Everything is simple. When dialing a number, we start with the country and region code and then only dial the local number for that region. For example, if in Kazakhstan you call number 8727-555-4433, then 8 means access to intercity. 727 is the city code of Almaty, and 555-4433 is a local number somewhere in Almaty. By the same principle, you can call anywhere in the world and talk about anything. We already know that using the internet, we can transfer data to anywhere in the world using IP routing. Each device on the network has its own IP address, a unique identifier. Each IP address consists of 4 octets. Each octet can store a number from 0 to 255 inclusive. For example, 192.168.1.17. Like an IP phone number, an address contains a network part and a host part. How to determine where in the IP address is the network number and where is the host number? Before we delve deeper into subnet masks, let's discuss IP address classes. IP addresses are divided into classes A, B, C, D, and E. For the purpose of subnetting, we will focus on classes A, B, and C, as they are commonly used in networking. The class of an address is determined by its first octet, so the range from 1 to 127 belongs to class A, the range from 128 to 191 belongs to class B, and the range from 192 to 223 belongs to class C. Each class has a default subnet mask. In the subnet mask, 1s indicate the network part bits in the IP address, and 0s indicate the host part. So 255 means that the whole octet belongs to the network part and 0 to the host part. It is enough to know the class default subnet mask to determine the network and host parts. Let's look at IP addresses and try to determine the network and host parts using the class and subnet mask. Consider the IP address 15.221.175.16. The first octet contains the number 15, which means that the IP address belongs to class A. The class A subnet mask indicates that the first octet stores the network number, and the second, third, and fourth store the host number. So 15 is the network number, and 221, 175, 16 is the host number. Consider the IP address 151.24.28.117. The first octet contains the number 151, which means that the IP address belongs to class B. The Class B subnet mask indicates that the first and second octets stores the network number, and the third and fourth store the host number. So 151.24 is the network number, and 28.117 is the host number. Consider the IP address 201.158.65.108. The first octet contains the number 201, which means that the IP address belongs to Class C. The Class C subnet mask indicates that the first, second, and third octets stores the network number, and the fourth store the host number. So 201.158.65 is the network number, and 108 is the host number. But how to calculate the network number and host number if not using the default subnet mask? Imagine a subnet mask written in octets. Note that in the subnet mask, first all ones go and then all zeros. It is an axiom. Let's fill in the IP address by octets using the conversion from decimal to binary. Select the network part using the ones in the subnet mask. Select the network part using the zeros in the subnet mask. The network part of the IP address is obtained by performing a logical AND operation between the IP address and the subnet mask. Let's convert from binary to decimal in octets using powers of 2. As a result, we get the network number 171.15.160. The host part of the IP address is the remaining bits after the AND operation. The host number 9.42. The same rule for calculating the network and host part is used in all other cases. In conclusion, IP addresses are divided into classes A, B, C, D, and E. Classes A, B, C are used in networks. The IP address class is determined by the first octet. The network portion of an IP address is obtained by performing a logical AND operation between the IP address and the subnet mask. The host part of the IP address is remaining bits after the AND operation.